All right, so number 6 asks us to graph this function without the use of a calculator, okay? So the first thing they ask for are x-intercepts. Well, in order to find your x-intercepts, you have to use the quadratic formula. All right, so again, we'll write it down just in case you need it. All right, so there's quadratic formula, okay? And as I start to input these values, I do x equals the opposite of b, which is -6, plus or minus the square root of b squared, which is 6 squared, you get 36, minus 4 times your a value, which is -1, times your c value, which is 8, all over 2a, or in our case, 2 times -1. I always like to do the square root function first, so I'm going to do that over here. It's the square root of 36, and I'm going to count my negatives. I've got 2 negatives, turn it into a positive. 4 times 1 times 8 is 32. So I get the square root of 68. Okay, now, square root of 68 is not a perfect square, but I can break it up into 4 times 17, right? Yep. Which reduces to 2 root 17. Okay, so we substitute that back in. -6 plus or minus 2 root 17 all over -2. Okay? All right, so I'm going to break these up and reduce them. This, when I reduce that, gives me 3 plus or minus. When I reduce this, 2 divided by 2, these 2's will cancel, so I'll just get the square root of 17. Okay, now, it is very hard, like this is the answer, these are my x-intercepts, but it's very hard to know where these are at. So we're going to have to, because I don't have the use of a calculator, I know that the square root of 16 is 4. So the square root of 17 is going to be like 4 point something. It's going to be really close to 4. So if I do 3 plus 17, square root of 17, which is pretty much 3 plus or minus 4 point something, maybe 4.1, we can assume. Remember, we're just guessing. I'm going to be around 7.1-ish. And if I subtract them, I'll be around -1.1. Okay? These are my x-intercepts. All right. Let's cross them out. Let's go to the next part. You do a y-intercept. Okay, y-intercepts occur when x equals 0. So if I take my original function, which is up here, and I plug in 0 for my x's, this is what I'll get. I'll get -0 squared plus 6 times 0 plus 8. Okay, well that becomes 0, that's 0, I just get c, I just get my 8 value. So my y-intercept, I put in 0 for x, I get out 8 for y, there's my y-intercept. Okay, let's keep going. Vertex. Formula for the vertex. X equals the opposite of b all over 2a. So again, I look at the top. The opposite of b should be -6 over 2 times my a value. My a value is at -1. I'll get -6 over -2, which is 3. Okay, 3 is my x value. I don't know what y is until I plug 3 back into the original function. So let's go ahead and do that. So I have a negative sign. I take out x and I plug in 3 in parentheses. I square it. Plus 6 times 3 plus 8. All right, -3 squared. So I do 3 squared, which is 9, attach the negative. So it's -9 plus 18 plus 8. And when you add those 3 together, I get 17. So my vertex is at 3, 17. Okay, so again, I've got all the major points here. I've got all my x-intercepts. My intercepts are around 7.1 comma 0 and around negative 1.1 comma 0. Right? We had to guess a little bit at those. I have a y-intercept at 0.8 and I got a vertex at 317. So why don't we put these on the graph? Okay, so I can have a better look here. All right, I got to go all the way up to 17. My graph doesn't do that. I only go up to 2, 3, 4, 5, 6, 7, 8, 9, 10. Only my graph goes up to 10. So I'm going to scale my y-axis by 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay. Everything else, all of my y values got to go up to 7. 1, 2, 3, 4, 5, 6, 7. I can do that. I don't need to scale my x-axis. Okay, so let's start putting these points down. It's about 7.1 comma 0. 1, 2, 3, 4, 5, 6, 7.1. Be about there. And negative 1.10. So negative 1.10, right about there. I have a y-intercept at 0.8. So 0.8, remember I scaled my axis, is right here. And I've got a vertex at 317. So 3 on the x-axis and all the way up to 17 on the y-axis. Okay, that's where my vertex is. So I've got a nice picture of the left side of this parabola. It's right there. But I'm kind of missing that symmetrical point over here. So in order to do that, I put in my axis of symmetry. So the axis of symmetry is a vertical line that runs right through the vertex. Okay? We always write the axis of symmetry. Because it's a vertical line, it should always start x equals. And if you notice, where does it hit the x-axis? It hits it at 3. So my axis of symmetry is x equals 3. All right. Now in terms of the symmetrical point, this point from here to here, I've got the point on both sides. These points are symmetrical to each other. But I've got a point on the left side at 0.8, that y-intercept, but I don't have a point on the other side. So my question is, how far away is that point from the axis of symmetry? It's 1, 2, 3 spots. So if I go 3 more, I'm going to get to its symmetrical point. Okay, so this point is your symmetrical point, and it looks like it's at 6, 8. Okay, now that you have the other side of that parabola, you can go ahead and draw in the rest of your parabola. Okay, now I've got everything drawn. I've got everything they asked for. My x-intercepts are right here. My y-intercept is right here. My vertex is here. The axis of symmetry is written down. The symmetrical point is right here. The only thing I got left are all the key features. Now it's up to you guys to know the key features. I'm going to have them posted on the website. But if you're still having trouble with the key features, please come in and sit down with me so we can go over it.